All right, guys, let's talk about the last type of connective tissue. We've already mentioned loose connective tissue. That's very thin and delicate, right? It forms a lot of membranes in your body. Well, the last type of connective tissue is called dense. And there's a lot of different kinds of dense connective tissue. But the name should tell you everything you need to know. It's dense, it's harder, it's thicker, it's closer together. Okay? So this is densely packed collagen fibers. It's very strong. Okay? But it doesn't have a good blood supply. So that's a problem, isn't it? If it doesn't have a good blood supply, probably not going to be able to heal if it gets damaged very well, is it? It's going to take a long time to heal. And that's the problem with dense connective tissue. Okay? Now, you'll find that in your ligaments and tendons. So if you hear somebody who's torn an ACL, right? When they tear an ACL and they have ACL surgery, how long does it take them to get over that? Well, most of us know it takes a long time. It takes several months, maybe even a year, especially if they're an athlete or something. It may take them as much as a year to get over that tear. If they break a bone, though, they can be ready in 6 to 8 weeks, can't they? So bones will actually heal faster than tendons and ligaments. So if you tear a tendon and a ligament, it's going to take a long time to heal because there's very low blood supply through that actual tissue. Okay? Now, when we look at dense connective, obviously you can tell the difference really quickly between dense, remember that, and loose. Loose is loose. You can see why they call it loose. You get over here to dense, you can see why they call it dense. It's very well organized. There's not a lot of space in between the fibers, is there? You can see the fibroblasts there, and you can see the collagen fibers in there, and there's very little space, and they're very well detailed. They're very well laid out in a pattern, aren't they? So again, that makes sense why they call it dense connective tissue. Okay? Then you have something called cartilage. We all know what cartilage is. We've all seen it. We got it on the tips of our nose and on our ears and between our joints. That's where cartilage is. Cartilage is also a type of dense connective tissue. All right? It doesn't have a good blood supply either, which is why if you damage cartilage, it doesn't heal back very quickly. It takes a long time for it to heal. Okay? Now, the cells that make cartilage, and we're going to talk about this a little bit more later on, they're called chondrocytes. Cyte, anytime you see this word cyte, C-Y-T-E, guys, remember like in biology, cytoplasm, cytosol, cytokinesis. The word cyto, or cyte, means cell. Chondro means cartilage. So chondrocyte literally means cartilage cells, which is what we're talking about. They're in something called a lacunae. What is a lacunae? Never heard of a lacunae? All right. Inside, and I'm going to show you in a second, but the cell, say, is this big, right? Well, it lives inside an empty space, its own little home, I guess, inside the thick cartilage, okay, called a lacuna, or lacunae, plural, okay? And it's surrounded by the jelly-like fluid material called the matrix, the fluid stuff around it. Not that stupid Matrix movie. It's just called matrix, the material that's surrounded by, okay? Now, there are different types of cartilage, okay? One of them is called hyaline cartilage. Hyaline cartilage is one of the more abundant ones. It's white with abundant fine collagen fibers, the ends of your bones. So between each one of your bones, you have hyaline cartilage, okay? So in between each one of your finger bones, these bones here, these joints here, these big ones, you have hyaline cartilage, okay? Now that's what it's there for. It's also in the respiratory passages. You know, when you feel down here at the bottom of your neck, the trachea, remember that right there? You feel those little rings right down there? You can actually feel it if you rub up and down. If your neck is thin enough, which mine really isn't, you can actually feel the little rings of cartilage. That's hyaline cartilage. That keeps your trachea open, okay? So that when air comes down, it doesn't close off at all. Same thing's down your bronchial tubes, your bronchi, okay? Now, that's hyaline cartilage. Then you have elastic cartilage. Elastic cartilage is the stuff in your ears and your nose, okay? Makes it nice and stretchy. That's why you can take your ears and you can flop it all day long, but it's also kind of stretchy. You can pull on it, can't you? All right, so that's elastic cartilage. It's even in the parts of your larynx, your voice box down in here, okay? You know, when you take your hand and you feel it right there and you feel the vibrations as you speak, that's your larynx. You know, guys, they call it the Adam's apple back inside there. That's made up of elastic cartilage because it needs to be stretchy. Then the last type is called fiber cartilage. Fiber cartilage is very tough. It's very strong. It's a shock absorbent. So you'll find that in your backbone. You know, those discs, you've all heard about the intervertebral disc, the disc between, you know, you've heard people had a ruptured disc or a bulging disc or a slip disc or degenerating disc or something like that. That's those discs between the vertebrae. And they're there so when you walk and you bounce, they create a little shock absorber. You'll also find them in your knees. Okay? You ever heard of the meniscus? The meniscus is a shock absorbing pad in your knees, which we'll get to a little bit later. The pelvic girdle, which makes sense. You want to have some shock absorption in your hips because when you land, boom, all that weight comes down in there and in your knees as well. So that's where you'll find fibrocartilage. Okay? Now, when we look at it, here's some examples. You can see what I'm talking about. I'm going to blow this up a little bit. These are the cells. All right? Here's the chondrocyte. These are chondrocytes. And they're inside an empty space right here. See, all this is the solid cartilage matrix. The cell is sitting inside an empty space inside of it called a lacuna, or lacunae plural. Okay? So there's the cells. There's two of them in here, and then this empty space is the lacuna. And the rest of this is the matrix, the material between all that, the solid material that makes up the cartilage. Okay? Here's another example of a different kind of cartilage. You can see the elastic fiber, so this is probably, again, the stretchy kind you'll find in your ears, the elastic cartilage. Excuse me. Here's the cells, there's the lacuna. Okay? But you can see it kind of looks like Swiss cheese a little bit. Okay? So that is the cartilage. All right? Now, let's go to something a little bit stronger. That's also connective tissue. It's called bone. You already figured this out. Bone is called connective tissue because it connects all parts of your body. Your body's all connected by bones, isn't it? You start from the tip of your toe all the way to your head. Without your bones, you'd be a blob of snot on the floor, wouldn't you? So we need bone, and bone is the thickest, it's the densest, right? It's got minerals in it. Remember, most people think calcium, think about phosphorus, magnesium. There's all kinds of minerals inside of your bones. That's what makes them so hard. All right? And again, there's matrix. But please remember, bone is living tissue. There are cells, just like in everything else. There's cells inside your bones. Your bones are alive. That's why they grow when you get to a certain age and you start growing up. Now, they support the body, no kidding. They protect it. They form attachments for muscles and blood cell formation. You've heard of bone marrow, right? That's where they make bone marrow. Bone marrow makes blood cells. Okay? So we know that bone is an extremely important type of tissue, but it is a type of connective tissue. Okay? Now inside of it, there are cells called osteocytes. Osteo means bone, cyte means cell. Now bone is kind of a weird one, and again, we'll get into the details of the makeup of bone and what it looks like when we get to the skeletal system. Excuse me. But the cells are arranged in circles. It's kind of like a target. You got a circle within a circle within a circle within a circle. Okay? Those circles are called osteons. Okay? And the cells are arranged around that osteon in different spots. I'm going to show you what I'm talking about in just a second. Now, bone has a good blood supply. There is blood. Here's the thing. When you break a bone, you're actually going to break blood vessels. There's blood vessels running throughout your bones. So your bones do bleed when they get broken. Okay? They also have nerves. That's why when you break a bone, it hurts, because they're nerves. So bone are organs. Bones are organs. They have different kinds of tissues in them. But bone is a type of tissue. That's why you can break your leg and be able to walk on it within a couple of weeks. You break your arm, 6 weeks later, it's back to normal. Okay? Now, when you look at bone, you can obviously tell real quick what bone looks like, right? Every time I look at it, I think of a tree. When you look at the growth rings of a tree, that's what I see here. If you look at this, this is an osteon. Here's another osteon. You see the little dark spots? Those are the cells. Whoops. Those are where the cells are located. There's an empty space called a central canal. That's where blood vessels are going up and down as well as nerves, okay? But there's the osteocytes inside of it. So when you look at it, easy way to identify this type of tissue is it looks like a picture of a cross-section of a tree. It looks like the rings of a tree, okay, the growth rings. So that was pretty easy. Excuse me. And then the last type of connective tissue, and most people, what? This is a connective tissue? Yes. And when I tell you, you'll be like, it doesn't make sense to me how it's connective tissue. Blood is connective tissue. How is blood a connective tissue? It's real simple. It goes everywhere throughout your body. It connects all your body together, right? Your blood goes from your toes to your head and through your nose, right? It goes everywhere. That's why it's considered a connective tissue. But it is a liquid, right? It's a liquid connective tissue. It's got blood cells, red and white, which again, when we get to blood and cardiovascular, we'll talk in greater detail. It's got a liquid matrix called plasma. We've heard of blood plasma before, right? And again, we'll get into great detail in another chapter about blood, okay? But that's what it's composed of. And again, its purpose to transport substances throughout the body. Oxygen to the body cells, carbon dioxide to get it out of the body, right? Food to get to the body cells, waste, cellular waste to get it out of the body, right? Send it to like the kidneys so we can get rid of it. So that's what blood is useful for. A lot of things, okay? But it's transporting stuff throughout your body, good and bad things, to get rid of stuff or to put stuff into the body that needs to have this material, okay? And when you look at blood under a microscope, it's real easy to identify. It looks like a bunch of little red dots. Every once in a while, you'll see different kinds of blood cells. You'll see white blood cells and platelets, but most of these are red blood cells that you'll see. They're kind of odd looking, but that's, again, pretty easy to identify what blood looks like under a microscope, to see those cells, okay? Now, those are the dense connective tissues, the other kinds of connective tissues, all right? If you have any questions, you need to contact me as soon as you possibly can if something isn't making sense. Now I'm going to send you a picture a little bit later of that last color diagram, what it should look like, okay? So be looking for that in your email later today. All right, we'll see you later.